In this video, I'll show you how to solve the ALEKS problem called writing the electron configuration of an atom using the periodic table. To help you solve this problem, let's start by marking up this periodic table. I'm going to show you how you could use it to come up with the electron configuration for any element on the periodic table. So first of all, I'm highlighting the elements in columns 1A and 2A. These are the elements that correspond to the filling of the s orbitals, and the particular s orbital corresponds to the number of the group or the horizontal row on the periodic table. So for example, these are the elements that correspond to the filling of the 1s orbital. These are the 2s elements. These would be the 4s elements, 7s, etc. You get the idea. On the other side of the periodic table, so all of these elements over here, these are the elements that correspond to the filling of the p orbitals. And also the number corresponds with the number of the row. So these elements are all corresponding to the filling of the 2p orbitals. And these would be the filling of the 4p orbitals. And then the elements that are in the middle, so all of these elements right here, these are the elements that correspond to the filling of the d orbitals. So these are the d orbitals. It is important to notice that the number of the d orbital, the principal quantum number, is one behind the number of the row. So even though these elements are in row number 4, they correspond to the filling of the 3d orbitals, and these would be the 4ds, these would be the 5ds, and these would be the 6d elements. So to come up with the electron configuration for any element, you're going to start up here at the top at hydrogen, and you're just going to read from left to right and from top to bottom and read off the periodic table, coming up with stopping at your element of choice, and that's going to give you the electron configuration. I do want to point out, you probably noticed that I highlighted this empty space and I did not highlight helium. When we're writing electron configurations, we like to pretend that helium is located in that spot and not in its normal location. Works better for electron configurations. So to come up with the electron configuration for this element that I have assigned to me, I'm going to start up here. I've got 2 elements in this particular spot, so that would correspond to 1s2, because I'm going 2 spaces in the 1s block. And then I'm going to continue reading from left to right. There's nothing else, so now I move on to row number 2. This is 2s. I've got 2 elements in that spot that I'm passing through, so that's 2s2. And then I keep going. Now I'm in the 2p area, 1, 2, 3, 4, 5, 6. So that's 2p6. And I'm going to keep going from left to right, from top to bottom. Now I'm here. I'm in the 3s, 1, 2. So that's 3s2. And then I move over here. This is 3p, 1, 2, 3, 4, 5, 6. 3p6. And basically you just keep doing this and you stop at your element. So I've been through all of these. Now I'm here, 4s, 1, 2. And now I'm in the d's. And remember, they're one number behind, so I'm in 3d. Oh, I forgot my 2. I'm in 3d, 1, 2, 3, 4, 5, 6, 7. 3d7. That's the full electron configuration for this element. Now looking at ALEKS problems, it wants you to use the noble gas abbreviation. For the noble gas abbreviation, you actually start in the row prior. So since our element that we're trying to write the configuration for is in row number 4, we're going to actually start in row number 3 with the noble gas. So we start at the end of the previous row, which is row number 3, and we write the symbol for that element in square brackets. So we write argon, and then we pick up from that element. We pick up from argon. So that would be 4s2 and then 3d7. Now, one thing that I noticed when I was looking at the solutions for this problem, ALEKS actually wants you to put this portion of the electron configuration in order of increasing principal quantum number. So it wants you to do the 3d7 part first and the 4s second. And that is not always conventional. That may not be how your textbook illustrates it. It may not be how your instructor illustrates it, but it is how ALEKS wants it done. So it wants not in the order that we would read it off of the periodic table, and not in order of increasing energy, but in order of increasing principal quantum number. It is still necessary for you to use this method in order to get the correct number of electrons, reading it off the periodic table, but then once you get that electron configuration identified, you're just going to rearrange it to get those principal quantum numbers in order of lowest to highest.